Let's say that we wanted to sketch the graph of x plus 2y equals 8. Notice that this x plus 2y, x plus 2y equals 8. Sorry, let me get rid of that. Shouldn't even be on here. As soon as I get ready to do something, all of a sudden go nuts here. All right, so notice that x plus 2y plus 8 is in standard form. Standard form looks like this. ax, oops, ax plus by equals c, and where a, b, and c are integers. They're not fractions. So whenever you have an equation in standard form, you can graph it by finding step one. Steps are, number one, find the intercepts. And by intercepts, I mean the x and y intercepts. And then step two is connect them. So that's what your steps. Find the x, y intercepts and connect them. To find, so to find the y intercept, let x equals to 0 and substitute into the equation. So to find the y-intercept, let x be equal to 0 and substitute in the equation. Well, here's the equation. X plus 2y equals to 8. So let's make that big there. Okay? All right. So I'm going to let x equal to 0. And then I'm going to substitute. So I'm going to take this, clone this, and instead of putting x, I'm going to change this to 0. Oops. Ooh, wow. 0. So I'm letting x right here, I'll make that red so you can see tomorrow. Let x be equal to 0. That's the most important step. Okay? Let x be equal to 0. That's step one. Once you do that, then you just simplify. Okay? I'll just clone that. So 0 plus 2y is just 2y. And 2y divide 2y equals 8. To get rid of the 2, you're going to solve for y, so we're going to divide both sides by 2. Okay? So how am I going to do that here? So if I divide both sides by 2, then here's what I do. I know what I do. I'll just do this and do that. Then I'll do this, do that, and I'll divide both sides by 2. So I divide it by 2, divide this by 2, and that's just going to give me y is equal to 4. So y is equal to 4. So what does that mean? That means when x is 0, y is 4. So that means my first point is x is 0 and y is 4. That's one of my points. So this is called my y-intercept. A y-intercept is 0, 4. So to find the x-intercept, and I'm just going to clone this. To find now, what if I want to find the x-intercept? To find intercept, let y be equal to 0 and substitute into the equation. So let's take the equation here, clone it, bring it down. All right. So this time I'm going to let x stay the same. X will be. And this time I'm going to let y be equal to 0. Okay. So now let's take this. What if I make the y a 0? Well, then that's going to give me, that's just going to give me, if I just clone this again, well, 2 times 0 is just 0. And x plus 0 is just x. So x is equal to 8. So when y is 0, x is 8. So that gives me my x-intercept. Sorry, I want that to be. My x-intercept is the point where x is 8 and y is 0. So I got my x-intercept is 8, 0, and my y-intercept is 0, 4. So let's go ahead and do the graph. And I'll just do like a version here. Let's see, this is just a row there. And let's see, let's draw a line there. Okay. And let's see if I can get a point here. I just use a little, see, yeah, there. I'll just let that be one of my points. Okay. And let's see, maybe I'll fill it in too. Just fill it in. Oops. Fill it in. Properties, solid fill. There. That's good. And let's, yeah, that way I can make one. All right, so let's do let's do our x-intercept. So we'll move this here. That's 8, 0. All right. And then let's do our y-intercept. Going past here. Our y-intercept. So our y-intercept, 0, 4. So the equation of the line, I just need to connect these two. All right. And let me go ahead and extend it a little bit, because then I can ask you something else about it. If I draw this out perfectly close, yeah, that's close enough. Yeah. All right. Now, maybe another question that we can ask about this. Now, this is the graph of x. So, this is the graph of x plus 2y equals 8. Now, since we have this graph, we ought to be able to write it in slope-intercept form as well. If you look at this graph very closely, and let's see, maybe I can zoom in. Oh, that's big. Yeah, zooming in. If you look and you can kind of see what the slope is. It has a run. If you look at it, it has a rise here. If I can just use a, it here I have a rise of, I know that's really big, but here is 4. This is a -4 going down. All right. So, oops, let's go down. Let's see, let's clean all that up. Okay. Here, if you notice, if I'm going down here, if I can use my fingers here. All right. Here I got oops, don't want to do that. All right. I think I got it back on track, didn't I? Let's see. Yeah, that's pretty close. All right. So look at here. If I look at the slope here, if I can just get a red line here, I can see a rise here of -4. All right. And here, if I look at this run here, and let's see if I can get a blue line here, I get a run of 8. So, oops, boy, I tell you. So my question is, what is the slope of this line? Well, the slope of this line is a -4/8. So the slope, which is m, is a -4/8, which is the same as a -1/2. And what is the y-intercept? Well, here's your y-intercept right here. If I can just draw a line to it. This is your y-intercept. And of course, we already knew what the y-intercept was from earlier. Okay? Yeah, the y-intercept was 0, 4. So since the y-intercept is 4, then that means since y is equal to mx plus b, this is called slope-intercept form. Slope-intercept form means that the equation of my line is y equals to a -1/2 x plus, well, actually not plus 4, plus, where's my plus? Plus 4, okay? Because my y-intercept is 4, all right? Because that's this point right here. That's 0, 4. All right? See, that's 1, 4. This right here, by the way, is just a run. All this is just all that is just the rise, okay? We use this in order to figure out the slope. So there's your rise, and there's your run. Just want to make that match color-wise. All right? And that's how we figured out what the slope was, okay? So that's a lot. So if you need to see this again, therefore replay the video again. All right? And try it with some of the other problems on that sheet. Okay? In this video, we want to write the slope-intercept equation of a line in point-slope form. A point-slope form, if you remember, looks like this. Y minus y1 equals m times x minus x1, while x1, y1 are the coordinates of a point on the line. There are 2 steps to do this. First, you must solve the equation for y, and then second, you must simplify using the distributive property. So let's take an example. Let's say we have the example of, let's see, y plus 3 equals 1/2 x minus 2. Okay? So let's say this is our example here. Now, what this actually is, this says this is the equation of a line that has a slope is 1/2, and it goes through the point 2, -3. All right. How do I know this? Well, my slope is right here. This is my slope because that's where m is. See? And if you look at my x1 is actually positive 2. See, it's supposed to have a negative, it's supposed to have a minus in front of it. So if this is a minus, then the x1 is just positive 2. But look what happened with y1. Y1 is you got a minus, you got here a plus 3. And since there's supposed to be a minus in front of it, that means this really is a -3. What happened is you had y minus -3, and those negatives canceled out, and so you ended up with a plus 3 here. So here, this is the equation of a line that has a slope of 1/2 that goes through the point 2, -3 in point slope form. What we want to do is take this equation and rewrite it in write it in slope-intercept form. And what does slope-intercept form look like? Slope-intercept form, you remember the last video, looks like this. And I'll go ahead and copy this. So this is what slope-intercept looks like. If I can just copy that. So we want it to look like this. That's slope-intercept form. So the first thing we're going to do is solve for y. So to solve for y means that we need to get y by itself, and the only thing that we need to get rid of is the 3. So let's subtract 3 from both sides. So what I'm going to do is I'm actually going to write this slightly different. I'm going to copy this, and I am going to subtract 3 from both sides. Like that. All right. And actually it would help if I made this red. Okay. Let's take this slope here and just make it regular color. And let's take this 3. All right. Just to show you that we're solving for y, we're going to eliminate the plus 3 by subtracting 3 from both sides. Once we've done that, we'll end up with this. Y equals 1/2 x minus 2 minus 3, which we need to simplify. Okay, so we need to use the distributive property here before we can do anything else. So let's find this. Actually, if you remember, to use the distributive property means that you got to multiply that 1/2 times the x and 1/2 times the 2. Okay, well, minus 2. So let's do that. We're going to get y, and I sure didn't want to put a y there. Okay, so let's do that. We'll get y equals, what is 1/2 times x? It's 1/2 x. Minus, what is 1/2 times 2? Well, that's just 1. So it's a minus in front of it. Now with the parentheses are gone, I can bring down my minus 3. And of course, we can simplify. I don't want to put that little arrow there. We can simplify this part. -1 minus 3 is just -4. So our final answer is, and I'm going nuts with these arrows here. Our final answer is y equal to 1/2 x minus 4. All right. Y equals 1/2 x minus 4. And so, and if I can just take that, make that a little bigger. That's what we wanted. Okay. Now we can see that this works. If we graph y equals 1 half x minus 4, and I'll actually do that on a calculator this time. It might take a second for that to come up. And while I'm waiting for that to come up, well, I think it'll come up pretty sick. It'll come up pretty quick. All right. What we're going to do is graph y equals 1 half x minus 4. Just do it on a calculator. All right. I don't need this. Close. All right. So here we are on the calculator. Let's go to a graph screen and let's put in, and let's turn on our grid menu 2, 6, 3. And let's type in y equals 1 half x plus 4. We graph that, we get this line. Now what we want to see is let's use graph trace and check that point. So if we go back, y equals 1 half x minus 4, it looks like it's supposed to have a minus 4, not a plus 4. So let's fix that. Double click on this and make this a minus 4 instead and press enter. Okay, that's more like it. All right. And if we look at the point 2, 3, and I'm going to actually go ahead and put it on here. Let's use graph trace. All right. There it is. Look what happens. Press enter. Okay. Escape. Let's see. Let's see. You can't really see it there. Look at that. Oh, that's probably not good. There. So look at that. This is a y-intercept. Look at 2, 3. If I go up 1 and over 2, I end up at 2, 3. So negative 3 is on the line. So that is what what we've done is we found an equation that has a slope of 1 half that contains a point 2, negative 3. And that concludes this video. Okay, these last two examples we'll look at are pretty simple. Write the slope-intercept form of a line with a slope of 7/5 and a y-intercept of 3. And if you remember, slope-intercept form is y equals to mx plus b. That is slope-intercept form. So if the slope is 7/5, that's m. So let's just clone this. So this is m right here. So m is slope, and the y-intercept is b. So let me go ahead and make that blue. And let's make this m red. So again, we'll make it, so look where m is, look where b is. So since our slope is 7/5, we're going to put 7/5 there. Okay. And since our y-intercept is negative 3, we're going to put a negative 3 here. We'll just, okay. Now, whenever you add a negative, that is the same thing as subtracting. So let's just simplify this to just, instead of doing plus negative 3, we'll just put negative 3. And that is your answer. That is your answer to this problem. Okay. And finally, we want to write the slope-intercept form of the line through a point with the given slope. Here's our example. Let's say we wanted a line through, we'll let it be through negative 5, 4. And we want the slope to be negative 1. Okay. All right, so let's do a line through 5, 4, and slope is negative 1. Well, we're going to use the point slope form here. So I'm just going to take that move out. We'll start with that. So let's substitute inside of the formula. If I can just clone this and replace. My y value is 4. So I'm going to put a 4 there. Oops, that is a small 4, isn't it? Good. Let's see if that's much better. Okay. And then let's see, and I actually don't need this to be bold. So if I can just give me regular color, please. That's good. And let's get rid of the boldness. Let's lose the boldness. All right. So this is y1 is 4. I'll keep that one blue. Yeah, I keep that one 4. And then x1 is negative 5. So I'm going to put a negative 5 here. Okay. Again, I got that little small one. Get rid of that. Let's put a negative 5. Now you notice I got 2 negatives. So maybe that would look as confusing if I did this. Okay. There. It's better. So, because x is, you're subtracting whatever x1 is, and x1 is negative 5, so I have to subtract it. Okay. So we can simplify this. Okay. Let's take this and let's clone it and simplify it. Oh, we know what m is. M is negative 1. So we'll put a negative 1 there. Okay. So let's simplify this. Clone this. And instead of doing x minus negative 5, we realize that that is the same as x plus 5. Okay. So we can simplify this. First thing we want to do is let's get y by itself. So we are going to, let's subtract, let's add 4 to both sides. So I'm going to copy this over. And I'm going to add 4 to both sides. There. There. Okay. Looks funny with one being, let's make that red. Okay. And let's get rid of this. Be consistent with our colors here. All right. Okay, let's keep going. All right, so I added 4 to both sides, so my y would be by itself. And now I got to use the distributive property. Put some arrows there just to remind you how it works. Yeah, I got a weird upside down arrow. Let's try the right arrow. There. Okay. What is negative 1 times x? Well, negative 1 times x is just a negative x. All right, and negative 1 times 5 is a negative 5. And then we got a plus 4. Okay, and this is easy to simplify. We know that this is equal to y equals to negative x. And we know that negative 5 plus 4 is equal to a negative 1. And so we have our final answer there. Y equals negative x minus 1, which we can also write as y equals to negative 1 minus x. Either one of these answers is fine. Okay, so you might see either one. But this is the slope-intercept form of a line through the point with the slope through negative 5, 4, with a slope of -1. And there's a slope. So, I mean, there is the equation. Let's check it out just to make sure it works. Okay, so let's go to a new graph page. Let's turn on our grid. Let's see if I can move this out the way. Menu 263. All right, and I'm gonna do a little backwards this time. This time I'm gonna put the point in for first. So let's see. The point is -5, 4. So I'm going to find -5, 4 with my point on function. Let's see, point. And let's go to -5, 4. Should be that. Let's see. What? Point on -5, 4. All right. And just to make sure we got the point, I have Inspire to tell me that that is the right point. Got this? So, yeah, -5, 4. See? Yep, -5, 4. All right. So, what is the equation of the line? So, let's type in the equation. We said that it was a negative x minus 1. If we did this right, that point will be on that line. And of course, it is. And you can tell that this line has a slope of -1. So, it looks like we did well there. And that concludes this. Well, I don't, oh God, now I'm showing my face. That concludes our videos. All right. Good. If you need to see it again, just rewind the video. Okay. Have a wonderful night. Good luck on the test.